Question 5 asks if these two triangles are similar, and if so, what is the scale factor? So to figure out if two triangles are similar, we can, there's a couple different ways to figure it out. One is the side angle side rule, and in this case we've been only told one side length of this triangle on the left, so we can't use this rule in this case, but we can use a different rule, which is the angle-angle rule, and this one says that if you have two angles between your two triangles that match up exactly, then you know that all three angles between the two triangles are match up exactly, because we know that the angles in a triangle have to add up to 180 degrees. So you know that all the angles match up, and then that means that the triangles are similar. So in this case, we can see that in the triangle on the left, we have 30-degree angle, a 15-degree angle, and on the triangle on the right, we have 30 degrees and 15 degrees as well. And then using our rule that 180 degrees is the sum of the angles in a triangle, we can figure out that the third angle in both cases is 135 degrees. So now we know that all the angles in our triangles are exactly the same. This means that they're similar, so we can say that, to answer our question, yes, the two triangles are similar. We found that out by the angle-angle rule. Another way of writing this, we can remember our notation, is by using the squiggly line to say that triangles are similar. And in this case, we would have to label our vertices for the triangle. So we could say, let's call this A, B, C, and we have to make sure that when we write this, our vertices match up to the right angles. So if I made my 30-degree angle at vertice D, that means that if I put E and F here, I can say that triangle A, B, C is similar to triangle D, E, F. So it has to be in that order to be correct. Moving on to the rest of the question, now that we know that the triangles are similar, we can figure out the scale factor. And the scale factor is given by the variable k. This is just the ratio between any two matching sides of our similar triangles. So in this case, let's see what we have on the triangle on the left. The only side value we've been given is 17.2, and this is on the side between our 30-degree angle and our 135-degree angle. So we want to match that up to the same side or to the similar side in the other triangle. So that's going to be this value here, 8.6. So these are the values we're going to get to find our ratio, and you can actually put either one on top, but I'm going to just put 8.6 on the top and 17.2 on the bottom. And dividing this out actually gives me a value of 0.5. So I'm saying that going from the triangle on the left to the triangle on the right, I've shrunk it down by a scale of 0.5. So 0.5 is our scale factor. If we had flipped these two values in the ratio, we would have gotten a 2 here, and that's just what we would have to remember, that we're going, in that case, from this triangle on the right to this triangle on the left. But both of those are fine answers for the scale factor. And so by proving that these triangles are similar and finding our scale factor, we've answered question 5.